Hello. In this session, we'll talk mainly about file sharing, which basically is between two or more processes. Here, I'm going to take example of two processes. Now, with this file sharing concept, it is assumed that multiple processes would be accessing shared files for reading and writing purpose. And like we know that there can be access permissions that may be defined so as to prevent conflict and ensure consistency. And when multiple processes need to read or write, when I say read from or write to the same file, the file sharing mechanisms ensures data consistency and prevents conflicts. Now, when we do deal with this file sharing aspect, methods can be read-only file sharing, where multiple processes can read the same file simultaneously without conflict. And second can be write-only or read-write file sharing. Here, multiple processes write to a file and the conflicts can occur at some point of time. And there can be multiple ways rather to prevent such kind of conflicts. One can make use of file locks or one can make use of atomic file operations. And even one can think of making use of permissions and ownerships with by making use of Unix file permissions. The example that I'm going to introduce here is assuming that there is a file with some name. This file would be shared between two different processes. So we are going to make use of different system calls for here for sake of making use of this file sharing with more than one process. This program would be demonstrating how a parent and child process are writing to a shared file using fork. Now, while I have written this code, I'm assuming that the parent process would be writing numbers from 1 to 5. And further, the child process will be writing numbers from 6 to 10. Now, when parent and child starts writing, it can happen it depending upon the scheduling policy at that time, at that point of execution time. Either of the process may be given chance. It may happen like only parent is finishing and then child is working out. Or it may happen like parent is given chance, it printed one, then child is printing something else, then again parent, then again child, again parent. This order may vary with respect to execution perspective. Now, from execution point of view or from program point of view, I have used again different function calls here. So one of the function call that I would be using is open. Now it is similar to like your fopen function in C makes use of internally this open function. Now, if that file is not there, automatic file creation is done internally. So there can be a create function too. We already used fork. So fork creates a new child process. Now, when we use, say, call, for example, man wait, we used it for in a parent process, if you recall, because we want the child to finish and then only parent should terminate. That's why we will be using wait system call here. Now, while we are using open, similarly, we will be using close function. Okay, or close system call. So this would like both of them would be taking file descriptor as an parameter. So as we want child also to be there subsequently executing, so we'll be using sleep function the way that we used in earlier case. I'm going to make use of one variation of printf. Okay, suppose if I write man3 printf, you will see that there are multiple printf versions. So we'll be using specifically this kind of function dprintf. Now, if you see dprintf, it takes the file descriptor, okay, here, and the string to be printed. So we are going to make use of this because we want to write to that file descriptor. Because we are making use of open, we are making use of close. Okay, so let us see the code. So like this, if you see, I have again used in header 4 different files. Okay. Now I have created a file descriptor integer variable, which would be storing descriptor of a file, which would be created or edited. Now here, I'm assuming that I would be having this file ca5 underscore 552mj.txt. This would be open in write only mode. And if not available, then create with read write permission 666. Now suppose because of some reason a file cannot be opened, then we are returning an error with p error function, which is a standard function to display the errors from the system. And then we are calling exit. Now we file is created, then through fork, we are going to execute the following code here. So this is the code that would be executed in a child, and this is the code that would be executed in parent. And as I stated, as we used earlier too, we want uh, parent to wait till child finishes. That's why we are using this. And we are adding some 1 second delay in child process too. So if you see, both the statements are somewhat similar. Only thing is like here we have written child, here we are writing parent, and the values of I are varying from different places. Integer I equal to 6 to 10, and here we are printing from parent 1 to 5. And note here that we are using the same file with different processes. Okay, so let us try to execute this code. First of all, we'll compile gcc-m32 file sharing.c. Okay, and now let us execute. So like the file we used, if we see, we used is ca552mj. So ls ca, let us write star dash l. So we don't have any file listed there. So we'll execute this code. Okay, and let us try to see. Now you may see one file is created. Now both, like while I executed, I will show you the output as well. So let me first show you what it created. You can see parent, parent wrote 1, child wrote 6, parent wrote 2, child wrote 7, child wrote 8, then parent was given chance, then child wrote 9, parent wrote 4, child wrote 10, parent wrote 5, and then terminated. Now, on what basis we are saying this? So let us execute this, and we'll write here ps-aux. No, we know that it terminated, but we will try to execute it one more time. So right now nothing. So let us execute this, and now we fire this. You can see 2 processes are created. Correct? They are into, now as it finished from here. Okay, you may see that the 2 entries are gone. So these were the processes created, and both the processes wrote the respective code from child part, from parent part. And output shown as we saw is this. Now suppose if I add append there, append permission, what will happen in such a case? If we permit append to, now what will happen? It will continue appending the data. Now you are seeing here that every time it is rewriting it again and again. Because we haven't written anything with respect to append. It might be probably trying to delete it. So let us try to add append as well. So what I'll be doing is I'll be copying this part, and let me add it here, and we'll write commit here. Okay. Here we have to add pipe. Fine. Now let us save this. Let us compile. Now what change I made? I added the append permission. So now out. Now you will see what is happening. It started writing again. This was output for earlier phase. Correct. 1, 2, 3, 4, 5, 6, 7, 8, 10. You can see the numbers written till 10. Now, if I see again the output, it is repeated. If I try to write it again, because it is sharing between two you will see one more cycle is added with respect to printing the values. So here, what exactly is happening? We are saying that two processes created, like one is parent, other one is child, and both of them accessing a shared file here. Okay, and as we are writing into the file, so that's why we specifically used dprintf. Dprintf is meant for writing in the file descriptor. And one more thing that we identified here is both parent and child write safely to the same file. Now, as before we added o append, that append permission, we saw that it is rewriting, deleting earlier contents and rewriting it. But when we added o append, it actually ensures that each write is atomic by avoiding mixed lines. And this is how the file sharing can be seen or used rather with respect to the process cooperation.